Hey, what's up, puppies? My name is Francisco, and I bet your banana that you have a name. I'm kidding. Well, Gay-Lussac was a physician and a chemical that was born in France the December 6th of 1778, and he died on May 9th in 1850. Well, Gay-Lussac was an expert about the gases. Well, he talked about the first law that is about when the temperature are more hot, the particles move faster, and when the temperature are more cold, the particles move lower. So that's about the.
Good morning, kids. How are you today?
Fine.
Oh, I'm glad that you're fine.
Thank you.
Well, in today's class, we're going to talk about Gay-Lussac. Gay-Lussac created a law about the pressure and the temperature. He said that the pressure and the temperature are proportional. For example, we have here in this square that we are supposing that. Who did this?
I don't know. Really?
Well, we are supposing that the red dots are particles, and in this case, we are supposing that the pressure is 0.25 and the temperature are 100 degrees Kelvin. And we are supposing that in this square is the same volume as this one, and the pressure is 0.50 and the degrees are 200 degrees Kelvin. As we can see, the gases here are kind of lower. Do you understand that?
I think so.
Well, I said that they are lower because of the temperature. Like, it is a lower temperature, the particles are kind of cold. So if they are cold, they are more joined. So it is difficult for them to move. And in this case, the temperature is higher. So the particles can move faster because of the temperature. So here we have 0.25, and he said, Gay-Lussac, that it is proportional. For example, we have the pressure one that is 0.25 and the temperature one that is 100 degrees Kelvin, as we can see here. And in the second volume, that is the pressure 2 divided into the temperature 2. As we can see, if we multiply this number by 2, it's equal to 50. And if we multiply 100 by 2, it's 200. Do you understand that? Or
yeah. Can I make the third one?
Yeah, you can make the third one.
Okay.
You only need to make this formula to have the third one.
Okay. So, if P2 divided by temperature is equal to P3 divided by temperature 3, it will be like 0.5 divided by 200, it's equal to 1.5 divided by, I don't know.
Exactly. Now, the only thing you need to do is rule of 3.
Okay,
Exactly.
okay. So we multiply 1.5 times 200 divided by 0.5. So
Exactly.
it's
600. Exactly.
okay. So
In the temperature 3,
let's erase this.
what is the result?
600 Kelvin. So
Exactly.
if the temperature is higher, it will bounce more, like a ball.
Yeah, exactly, like a ball. If you want, let's make an experiment to make the example.
Okay, let's do it.
Let's go. Let's do the experiment. Okay. For example, the ball is the particles.
Okay.
So, and the strength I make to this ball is going to be the temperature. Do you understand that?
Yes, so this is the volume, I suppose.
Exactly. This is like the recipient. Exactly. So let's do this. I'm going to throw the ball, but in a weak strength,
Okay.
like this. What happened?
The ball doesn't bounce a lot.
It just bounced, but a little.
Yeah, because the temperature.
the
is
temperature
low.
it's supposed to be lower.
Okay.
So now let's make a strength. Do you see what happened?
Yeah,
It bounced more.
because the temperature is higher.
Exactly.
Oh,
You
now
understand?
now I understand this. Thank you, teacher. You're the best.
I know more about the law of Gay-Lussac. We are going to make an experiment. To make this experiment, we need some materials that are glass, a candle, material to light up the candle, a plate, and some water to make the experiment.
So,
Well, the first step to make the experiment is to put on the candle on the middle of the plate, and then light up something. Then we need to light up the candle, and let's put the base on the candle. So what is happening here? The light disappeared, the water increased, well, the level of the water increased, and this happened because of
I think that it's because the temperature and the pressure of the gases decrease, right?
yeah, as Gay-Lussac said, it is proportional. If the temperature go down, the pressure go down too,
But why the water go up?
because of the atmospheric pressure.
Ah, now I can understand this.
And finally, we just how put up retire the glass. And this is all our experiment. I hope you enjoy it. That's it.
Understand the topic.